Hello and welcome to this video. In this video, we are going to be rotating the bird surface. When you rotate surfaces in Pygame several times, the quality of the surface can be lowered. If you are just rotating the surface once, then this should be okay. You should not see that much difference in the quality. The process of rotating surfaces involves having the original surface. So you actually need two surfaces. So you need the original surface, which has no rotation. And then you need the surface after it has been rotated. So once you rotate the original surface, you then store the value inside a variable, and then you mount that rotated surface using the blitz method on the display screen. Every rotation of a surface always starts from the original point. So when you rotate a surface, you first of all need to import the bird on a surface, and then you rotate the bird on the new surface that has been rotated. You then use the blitz method to mount the rotated bird surface on the display screen. So what I'm going to do, I'm going to create a special function that is going to handle the rotation of the bird surface. I have added the new function for the rotation of the bird. I've called it rotate_bird, and the function takes in the bird. Inside this rotate bird function, I have a variable called new_bird. This variable is going to contain the surface we want we've rotated the bird surface. I'm going to store it in the variable called new_bird. To rotate something in Pygame, you use the rotozoom function. So the way you access that is using pygame.transform.rotozoom. So the rotozoom takes in three arguments. The first is the bird surface that you want to rotate. The second is the bird movement. The bird movement at the moment, I've added a negative value so that it rotates the surface with the bird in the right direction. Sometimes when the bird is rotating during the game, you may not see the bird movement that well. So I have multiplied the value of the bird movement by 3 so that the rotation is slightly visible. The third argument this rotozoom takes is the default argument of 1, which is the scale. So when you are using the rotozoom function, there are two things you can do with the rotozoom function. You can scale the surface and you can rotate a surface. I will not be using the scale functionality of the rotozoom function. We only want to rotate the surface, so we will be using only just the rotation part of the rotozoom function. The bird movement variable here is going to control the angle in which the bird and the bird surface is being rotated. Once the surface has been rotated, we want to return the new surface, and we're doing that on line number 37. I have also added a line of code. Line number 89 here is a new variable that I added. This variable is going to store the rotated surface, and the rotated surface is going to be stored inside this function called rotate_bird. Another thing we need to do is mount the rotated bird surface. So here on line number 91, using the split method, I'm going to change this surface from bird underscore surface because this is the original surface. So I want to mount the rotated surface, which is stored in the variable called rotated bird. All right, so this is the surface I want to mount on the display screen because it contains the rotated surface. So I'm going to save that and then we can test the code again. You can see the bird rotated and you can see it's got a black background around it. I will explain the reason behind the black background. See, but you can see the different level of rotation for the bird. It can be difficult to notice the bird rotation while the game is running, so I have captured it just to illustrate. So you can see the slight rotation here. You can see the direction of the bird. That's one rotation. You can see another dimension of the rotation, and that's another one. You can see another dimension. So as the surface is rotated, it also rotates the bird. The reason we have a black square around the bird is that when the new surface was created, we did not provide any other values. So pygame thinks that we want a background and then draws a blank square background for us. So what we're going to do, we're going to tell it not to do that. To remove the black square around the bird, we're going to modify this convert function on line number 55. So when we imported the image of the bird, we also use the convert function. So I'm going to add another part to this convert function, which is called alpha, and that will prevent the black square being drawn on the bird. I have modified the convert function on line 55. I've added underscore alpha that will remove the black square around the bird. So if I run the code again, the black square should be gone. Notice the black square has disappeared and you can see the bird also rotating. Hello and welcome to this video. In this video, we are going to be animating the bird to flap. The way animation works with pygame is that you have to import multiple images you want to use with the animation. You then put all the imported images into a list and then you cycle through the list with the individual images consecutively at a certain speed. So that's how you create animation. So if you take a look at the illustration here, we have 3 bird images. Note that each of the images will have their own surfaces. So, and also notice the position of the flap. You can see this flap is down, this is middle, and this is up. So the flaps on the birds are at different positions. So we're going to be cycling through the list that contains the imported bird and then creating animation from that. So these are the images in the asset folder. We have the bluebird download flap. We've got the mid flap, which we are currently using at the moment in the game so far. And then we've got the up flap. So we're going to add the down flap and the up flap, including the mid flap, which we have already imported. And we're going to add that into a list. and then cycle through that list at a certain speed to create the animation effect of the bird flap. To begin, I'm going to make some changes to the bird underscore surface on line 55 and the bird underscore rect. So at the moment I have commented out the two lines of code because I'm going to be importing the 3 bird images, and then I'm going to put them in a list and will eventually cycle through that list to create the animation effect. I have made some changes to the code. So I've added the block of code from line 58 to line 64. So line 58, 59 and 60 are the bird images I have imported, and I've also placed them in a separate variable. So the variable name reflects the bird image that it is storing. So on line 58, we've got a variable called bird underscore down flap. So this is going to store the image of the bird with the down flap. Line 59 is the mid flap, and line 60 is the up flap. Notice I've used the convert underscore alpha function to prevent the drawing of a black square around the bird images. Line number 61 is a new list I've created called bird underscore frames, and this list is going to store the various bird images which are represented by the variables that stores the images. On line number 62, I've created a variable called bird underscore index with a default value of 0. This index variable will be used later to pick a specific surface from the bird list. By default, the index starts with a value of 0, which represents the first item in the list. So the second item in the bird list will have an index of 1, and the third item will have an index of 3. So at the moment we have a bird list with an index of 2. Since we need a bird from the start, I've created a variable on line 63 called bird underscore surface, and what is going to be stored in this bird underscore surface variable, we are going to store the bird underscore frames, which contains the list of the birds, and we are passing in the bird underscore index variable into that list so that we can select the bird from the index. So we basically take an item, in this case a bird, from the list depending on the index number. I've also created another variable on line 64 because we'll need a rectangle around each of the bird surface. So I've created a rectangle that will be placed around the bird, and that is going to be stored in the variable called bird underscore rect. And just like the commented code on line number 56, we are going to get the bird surface and place a rectangle around it, and we want it to be in the center, and the position for X is going to be 50 and the Y position is going to be 256. If I save the code and run the code again, the code should still work as it was previously. So the code still works. The only difference is that the bird flap is downwards because of the index number, which is defaulted to 0. The bird index is 0 by default, which means it will load the first bird, which has a down flap. So if I change this index to 1, it will load the second bird, which has a mid flap, And if this index is changed to 2, it will load the third bird, which has the up flap. The next thing I want to do is to cycle through the bird list at a certain speed. So I'm going to be using the same approach as the spawned pipes. So I will create a new user event that will trigger every couple of milliseconds, and each time it is triggered, it will increase the bird index by 1. So I'm going to replicate what I have done with the spawn pipe and the user event for that. So I'm going to do the same for the bird flaps. I'm going to create a new variable here. Just going to tab down, create a new variable called bird flap, which is going to be a new user event. So this is going to store the user event for the bird flap. I've also added a +1. This is because we want a different event each time. So the first event will represent maybe the first bird, and we want the second event to be the next bird, and so on. Next, I have added a timer on line number 67. This timer is going to trigger the event every 200 milliseconds. So the value of the bird index will change every 200 milliseconds. The next thing we have to do now is go into the event loop and check for the event using conditional statements. So I'm going to check for the bird flap event down here after the spawn pipe one. So I'm going to add another block of if statement to check for the bird flap event. I have added another block of code from line number 94 to 98. Line 94, we are checking for the type of event. We're checking if it is a bird flap, and if it is, we want to check the index. If the index on line 95, if the index is less than 2, don't forget that index is 0 base. So first item is index of 0, second item index of 1, and third item is index of 2. So we only have 3 birds in the list. So I'm saying on line 95, if the bird index is less than 2, then on line 96, I want to increase the bird index by 1. It will make the index 2. That is if the index is less than 2. If the index becomes 2, that means it has reached the maximum. That means it has reached the 3 items in the list. That block of code will now stop. It will now jump to the else block on line 97, where the bird index will be back to 0 again. So the way the code works is that at the start of the bird index is going to start with a default value of 0, and then on each cycle of the loop, it will increase by 1. However, when it gets to a maximum of 2 index, it will reset back to 0, and then the cycle starts again. The next thing I want to do is to create a new function that is going to be called bird_animation. This function is going to take an item from the bird list and then place a new rectangle around it. This is important because the rectangle has to have the same dimension as the bird surface it surrounds. So let's create the function. So I'm going to create a new function here underneath the rotate_bird function. I have created the new function from line 39 to 42. It is called bird_animation. Inside this function, I have a new variable called new_bird. this is going to store a new surface that is going to get from the bird underscore frames, and from that we are going to select the bird index. So this is what is going to be used to update the bird. I've also created another variable inside this function on line 41 called new underscore bird underscore rect. So this variable basically is going to create a new bird rectangle. We are going to position the new rectangle in the center, and the position from the center is going to be 50 pixels from the left, and then the value of y is going to be where the previous bird was. So we're going to use the same value from the previous bird location, which is center y. We don't want to change the position when the bird is being updated. And then on line 42, we are returning both variables, the new underscore bird and the new underscore bird underscore rect. When you create a function, in order to use the function, you have to call the function. So this function I've just created, I need to call the function in order for the function to be activated. So I'm going to call it inside the event. So we can see where we have the bird event, where the event is being checked. I want to call the function from here. I have added another line of code, line 103. This is where I'm calling the bird underscore animation function. So basically what I'm doing here is that I am taking the bird underscore surface and the bird rectangle, and they are going to get the values from the bird underscore animation function. The bird animation function takes an item from the bird list and places a new rectangle around it. Running the code again, you can see the different flaps of the animation. Hello and welcome to this video. In this video, we are going to be adding scores to the game. I will be implementing two types of scores. The first is going to be the score for the current game, and the second type of score is going to be the highest score, which will be the highest score for all the games played. So we are going to be storing these scores in variables in order to implement the adding of the scores to the game. The scores are basically going to be text, but before we can implement that, we need to understand how pygame handles text. So the process basically is to create a new font, which will include the type of font and then the size. We then need to render the font with the text we want to write and also the color. Once we've done that, it creates a new surface with the text, and then we have to place a rectangle around it. So we're going to use similar processes we've used before. To begin, I'm going to create a new variable and store the font inside that variable. Inside my project folder, I've already imported the font. So this is the name of the font, 04B_19. It is a true type font, so the extension is TTF. I've created a variable on line 53 called game_font. This is going to store the imported font, and the way you import a font is to use pygame.font.font. Notice that the font method, which is the one in blue here, has uppercase F. So the F has to be uppercase, and this function here takes in two pieces of information. The first piece is the type of font, which is the style. And then the second piece of information is the size of the font. So at the moment, I've given a size of 40. The next step is to use the font we have imported on line number 53 to write some text on the screen. I have created a function that is going to be used to display the text on the screen. So the function I have created is from line 44 to 47. Inside the function, I've created a variable on line 45 called score_surface. This basically is going to be used to store the text for the current game, which is going to be stored in a new surface. So this is going to be equals to the game font. So I created a variable earlier called game_font. So we're going to be using the render function or method on that game_font variable. So this is the variable that contains the font we want to use to display text on the screen. The render method takes three pieces of information. The first is the text we want to be displayed on the screen. So the text that's going to be displayed is going to be score. The second piece of information is basically the anti-aliasing. So we want to determine if the text is going to be an anti-alias. The anti-alias takes in a Boolean value. So if you want the characters of the text to be smooth, then you're going to set the anti-aliasing value to true. If you set that to false, then the text will not have smooth edges. The final piece of information the render method takes is the color of the output screen. So I've represented it here as 255, 255, 255 represents an RGB color tuple. RGB stands for red, green, and blue. With the RGB colors, you can mix them whatever way you like in order to give the desired output. So the range starts from 0 to 255. For example, in this example here, we have the red, which is 255, which is the maximum. So if I max out the green and the blue to 255, that will give an output of white. So you can see I've given all of them the same values, 255, 255, 255, and we get a white background. So the RGB colors can be mixed in whichever way you like. So if you mix them equally, for example, as I've done here, you get a white background. But you can play around with different values to get the output you require. So the background color for the output is going to be white because I've specified the maximum for the RGB colors. I have created a variable on line 46 called score_rect. This variable is going to store the rectangle that we are going to use to place around the text surface. So we are using the get_rect method to place a rectangle around the score_surface. And we also want to position it by 144 pixels from the left and 50 pixels from the top so that the text gets displayed somewhere near the top of the screen. On line number 47, I'm using the blit method to place the text surface and the text rectangle on the display surface. When you create a function, before you can use the function, you have to call the function. I'm calling the function here on line 24. So as you can see the text being boldly displayed on the screen. Although there are no scores being shown at the moment, we will start implementing that shortly. To begin, I'm going to create two separate variables. The first variable is going to store the current game score, and the second variable is going to store the highest score. To begin, I'm going to relocate this variable here called game font. I'm going to cut, and I want it to be placed here after the clock. So I'm just going to tap down, and then I will create the two variables underneath here. I have added the variables. Line 59 is a variable called score. I've set the starting default value to 0, and on line 60 I've got a variable called high underscore score, and the default value I've set to 0 as well. So these will be the starting points for the scores. Now that we've created the variables for the score, we have to reference them from this score underscore display function. So here on line number 45 inside the render method, I need to replace this hard-coded text that says score, and then replace it with the actual name of the variable. So I've replaced the hard-coded text with score, which is the name of the variable that contains the current score. The problem with this at the moment is that this render method only stores strings. Strings are basically text, but the value inside this variable called score is an integer, which is a number. So in order for the render method here to work well with this, we need to convert this score into a string. There is a special method for that called str, so we're going to use that to convert the value stored inside this score variable into a string so that it can work with the render method. So on line number 45 here, I'm using the str function, which is going to convert the value inside this score variable, which is an integer or a number. It's going to convert that into text. But I want to update the value. At the moment, the default value is 0. I want to be able to update it by a fraction, say 0.01, and that 0.01 increment is going to be a decimal, which is a floating point number. So we need to be able to convert that value into an integer. So to do that, I'm going to add a function called int, which will convert a value from float back into int. So on line number 45, I've added an int function. So the str converts from int to string, and then we're going to use the int again to convert the string back to an integer so that we can update by a whole number. So I'm going to implement that inside the game loop. So I'm just going to go right down to the game loop just before we call the function. You can see here, line 127, I'm going to update the value of the score variable by 0.01. I've already converted this into an integer, so it's going to display whole number each time the score is updated. So I'm going to save this and let's give it a quick test. So we should be able to see some scores now. You can see the score is being updated. I also want to display a high score, but I only want the high score to show up when the current game is over. So in order to implement that, I need to modify this function called score underscore display. I have enclosed the code inside the score display function inside two if statement blocks. In the first if statement block, I am checking if the game state is current. If it is the current game, then I want to draw the current score on the display screen. In the second if statement block, if the game state is equals to game over, then I want the current score and the high score to be drawn on the screen. So there are two if statements. The first will only display the current score while the game is running. The second if statement will display both the current score and the highest score when the game is over. I've also created variables for the high score on line 54 and variable for the rectangle that is going to be placed around that surface on line 55. There is a slight difference in the positioning of the value of y in the high score rectangle. I have positioned it on 425. Basically, this is going to appear towards the bottom of the display screen. I don't want the current score and the high score to be on the same level, so I want the highest score to appear on towards the bottom of the display screen. So inside the game loop, we've got the game active, this condition. So where I'm calling the score underscore display function, I want it to display the current score when the game is running. So I've passed in the text current underscore game, which is the string parameter I set in the function. So if we take a look at the function here, I've got the parameter here, current game, which is what I'm referring to when I am calling the function on line 138. I also want to display the highest score when the game is over. So if I run the game again, you can see the current score being displayed on top and it's also being updated, and then the highest score is going to be displayed on the bottom of the screen. At the moment, there is no text to indicate if that is a high score or current score. So I'm going to add some text to the numbers to show that this is a high score and this is a lower score. I will be using f-string to add a display text to the display screen that will display the text for the scores. F-strings basically provides a way to embed expressions inside a string. To incorporate f-string into the code, I'm going to modify the code on line 50. So I'm going to remove the string function and also the string function on line 54. So I'm going to replace that with an f-string. I have modified the code on line 50 slightly to incorporate the f-string. So this is the f-string and this is the text that will be displayed for the current score. And I'm also putting the curly brace around the variable so you can combine variables with actual string when you're using f-string. So it allows you to embed expressions inside a string. So that's what I've done here. I have replicated what I did on line 50. So I'm doing the same thing here on line 54. I've got the f-string and the text that will be displayed on the screen for high score is going to say high score, and I'm combining that with the value stored inside the variable called high underscore score, and I've enclosed that in curly braces. So you can see I've got the text now showing up as score and then high score. So if I start the game, you should see the different values being displayed. At the moment, the score for the game is not being updated correctly. So we are going to create a function that's going to take care of that. I have created a new function called update underscore, and I've passed in the score variable and also the high score variable. So what this function does is fairly straightforward. It's going to check if the value that is currently stored inside the score variable is greater than the value stored in the high score variable. If that is the case, then the value in the score variable now becomes the value stored in the high score variable. So if the score variable has a higher value, that value will now become the high score value. And since the high score variable is inside the local scope of the function, we have to return the value it stores. So we're doing that on line number 61. As usual, when you create a function, you have to call the function for it to be used. So I'm going to call this update function inside the game loop. Inside the else block, before the score underscore display function is called with the game over, I'm updating the value of the high score variable. And we're doing that using this update score function, and we're passing in the score variable and the high score variable. The final step here basically is to be able to reset the score for the current game when the game is over. If we do not reset the score for the current game back to 0, the score will keep increasing each time we start the game. So we have to reset that. And to do that, we have to go into the event loop. So inside the event loop, this block here where the game is going to be over, while we are restarting the game, we also want to reset the value of the current score variable, which is on line 116. So you can see here I've now set it back to 0. So as the game is reset, the value of the current score will also be reset to 0. So let's test it out and just see. So you can see the game has stopped, and you can see the high score is 3 and the current score is 0 because the game is over. So if I start the game again, the high score will be 3. So let's start again and see if I can beat that. The game is a bit difficult to play. So you can see I've not been able to beat my previous high score. So if I'm able to beat that, then the value will be updated. So at the moment, the current high score I have is